So we're finding the absolute maximum and absolute minimum of this function, a function of two variables, on the closed disk. It's basically the unit circle that's filled in. So to find the absolute max and absolute minimum, we'll first find the critical values and then we'll check the boundary of the region. Critical points are points where the partial derivatives are both equal to 0 or one of them is undefined. So let's find the partial derivatives of this function. So the partial with respect to x is going to be 6x squared. And the partial with respect to y is 4y cubed. They're defined everywhere, so they're certainly defined in the region. So let's set each of them equal to 0. We see that the only way we could get 0 in the first equation is x equal to 0. And in the second, y has to be equal to 0. So that gives us that 0, 0 is a critical point. And in fact, it's the only critical point. Next, we have to check the boundary. That's simply the unit circle. So it's all xy for which x squared plus y squared is equal to 1. Let's solve this for y squared and then plug it into our function. So y squared is 1 minus x squared. And then we can rewrite our function as a function of x. So we're going to call it g of x. It's basically the function restricted to the unit circle, which is just the line on the outside there. So this is going to be g of x is 2x cubed plus y to the fourth. That's y squared squared. So that's 1 minus x squared squared. So g is defined on the closed interval -1 to 1. So we need only take the first derivative of g and see where it's equal to 0, and then also test the endpoints, -1 and 1. So the derivative of g is 6x squared minus 4x times 1 minus x squared. And we set that equal to 0. There's a common factor of 2x, which we can factor out. So simplifying, we get 2x times 2x squared plus 3x minus 2. So this gives us so far that x is equal to 0, or 2x squared plus 3x minus 2 is equal to 0. Keeping in mind we're on the unit circle, that is x squared plus y squared is equal to 1. So when x is equal to 0, we either get y is 1 or y is -1. So these are 2 points that we'll have to check for max and mins. So this is the point 0, 1, and this is the point 0, -1. We also have to check the critical point we found earlier, which was right at 0, 0. So far we have 3 points that we'll evaluate. We'll apply F2 to see which one's the biggest and which one's the smallest. So this one is just 0, 0. So we took care of x equal to 0. That gave us these 2 points that we have to check. This is a quadratic equation, which we can factor. And if you poke around, you're going to find it factors this way. This means we can set each factor equal to 0. When we set 2x minus 1 equal to 0, we're going to get x is a half. When we set x plus 2 equal to 0, we're going to get x is equal to -2. But that's not inside of our region. So that's what we would call an extraneous solution. So we can disregard that. But when we look at x equal to 1/2 on the unit circle, we find that y has to be equal to the square root of 3 over 2 in order that x squared plus y squared be equal to 1. So this is going to be another possibility, and this is the point 1/2 the square root of 3 over 2. But we also have to consider there's a negative y value that also meets the criteria, and that's 1/2 negative the square root of 3 over 2. So those are both points that meet this criteria, and those are both possible points that we have to check. They're critical points of this function along the boundary, that is, along the unit circle. And then finally, we can't forget that this function g was defined along this closed interval from -1 to 1. So we do have to check the endpoints. The point -1, 0, and that's the point 1, 0. So we have a total of 7 points that we have to check. We'll evaluate f, and we'll find which one is the largest and which one is the smallest. So recall, this was our original function, and we're going to evaluate it at each of these ordered pairs. First, 0, 0. Plugging that into the function, we get 0. -1, 0, we find is -2. 1, 0, we find is 2. F of 0 minus 1 is the same as f of 0, 1, and that's just equal to 1. Then finally, f of 1/2 square root of 3 over 2. If you do the arithmetic, you'll find that's 13 over 16. And we see that f of 1/2 negative the square root of 3 over 2 is also equal to 13 over 16. So let's circle the values we got when we evaluated f. 0, -2, 2, 1, and 13 over 16. So that tells us that the max is 2, and the min is -2. So on this closed region, the function takes on its max at 1, 0 for a value of 2, and it takes on its min at -1, 0 for a value of -2. And thanks for watching.